Greetings to everyone. This is Senior 5 Chemistry in Organic Chemistry, and my name is Mugumya Osward, who happens to be your teacher today. Today we shall look at chromium. This is lesson 1 about chromium as a transition element. Remember we had looked at the introduction of transition elements. So we looked at different things: complex formation, how to name complexes, nomenclature, the structures, and all that in our previous lessons. So today we are starting on individual elements. We want to look at the chemistry of chromium, and this is lesson 1 about chromium. So we have our lesson objectives, which include that by the end of this lesson, all of us should be able to locate chromium in the periodic table and write its table electronic configuration. We should also be able to state different properties of chromium, or what we can call characteristics, and also be able to explain some reactions of chromium with common elements. When we talk of common elements, we mean like halogens, that is chlorine. We mean like maybe oxygen in air, and so on. So let's go deep into the details. So chromium has got atomic number of 24, and it is a transition element, and its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, and 4s1. So if you add up all those electrons, you get 24. So what we are having, the electronic configuration we are having is the stable one. But remember, if you are to follow the configuration tree, we shall find that at the end, instead of having 3d5, we would be having there 3d4, then 4s2. So this is the unstable one, the unstable configuration of chromium. So what do we do to get the stable one? We make sure that we promote one electron from the S sub energy level. Then we get 3d, 3d5, 3d5, then 4s, s1. So that is why we have this kind of thing here, that we wanted to have a stable configuration. Remember when we were starting this branch of chemistry, we said that whenever a sub-energy level is half-filled, that is the D, if it has 5, or if it is fully filled. If it is fully filled, that is when it has 10 electrons. Remember that this sub-energy level contains a maximum of 10 electrons. So if it has 5, it means that it is half full. If it has 10, then it is full. So if you have a configuration having such 3D sub-energy levels, it means that they are stable. It means that they are stable. So this is the stable electronic configuration of chromium. Then, given it is a transition element or a transition metal, it has variable oxidation states. It has +2, it has +3, it has +6. And we say that with the +3, it is the most stable one. So amongst all the oxidation states of chromium, +3 is the most stable. We shall also find that most of the compounds of chromium are in +3 oxidation state. But don't forget that some books also show that it has oxidation state of +4 and also +5. But these are rare. These are rare compounds, but it can also have such oxidation states. So chromium 2, here we are trying to write the electronic configuration of chromium 2. Chromium 2, that is when it loses, if it has For example, if we have 3d5, then for S1, it means that if we have oxidation state of +2, we are losing 2 electrons. So we shall lose this 1 electron in the S sub-energy level, and also 1 electron from the 3d sub-energy level. So that is why we are having 3d, 3d4, 3d4, then 4s0. We are supposed to write the 4s0, but for revision purposes, that's why we are writing it. We want to show that in the S sub-energy level, there is no electron. But if you are giving it as an answer, then there is no need of writing the sub-energy level without any electron. So therefore, chromium 2 loses 2 electrons. And remember, when we are losing these electrons, we start with the S sub-energy level, then we go to the D sub-energy level. Then if it is chromium 3, it loses 3 electrons. So remember, we had lost all the 1 electron we had in the S, and in the D we had 4. So if we lose the 3rd electron, it means that in the 3D we shall remain with only 3. Then if it is 6, it means that we are losing 6 electrons. That means that we shall lose all the electrons in the 3D5, all of them, and also the 1 electron in the S. So 3D loses all the electrons and the 4s as well. So we shall find that the compounds formed in +6 oxidation states, maybe they are not colored because of losing the 3D sub-energy level. Let's continue. Let's look at some properties. Why chromium is a transition element. This one explains why chromium is a transition element. So we can also take these ones as the proof as why chromium is found under the category of transition elements. 1, it forms colored compounds. For example, chromium 3 compounds are green. Chromium 3 compounds are green. In other words, they're not colorless. Secondly, chromium has variable oxidation states, as we said, +2, +3, and +6. Then to add on this, we shall find that compounds which are formed in +6 oxidation state, these are oxidizing. Remember, there is when we said that the higher the oxidation state, then the higher the chances of the oxidizing powers, having higher oxidizing powers. Then compounds of +3, we said they are stable, and we say that this is the most stable oxidation state of chromium. Then for compounds which are formed in +2 oxidation states, these are reducing agents, and again they are unstable. We continue. Then thirdly, chromium forms complexes. For example, we have this complex which is hexaamine chromium 3 ion. It is a complex. It forms many complexes. It can as well form a complex where it has a water ligand. We looked at this one when we are looking at how we can write complexes, how we can name them, how we can draw their structures in the previous lessons. In case you missed, then you will be able to get those missed lessons. That is, if you subscribe and you share the video. Okay, so it can also form a complex of this kind. This is aqua chromium 3 ion. Then next, chromium has catalytic properties. In other words, it can be used as a catalyst. For example, when you have a mixture of chromium 3 oxide and zinc oxide, That mixture catalyzes the formation of a methanol from carbon monoxide. Here we have the equation. So we are having carbon monoxide, which is a gas, with hydrogen, and we are forming methanol. So in the bridge here on the bridge, that's where we have our mixture. Remember, a catalyst does not take part in the chemical reaction. It just speeds up the rate of reaction. So that's why there is no need of maybe showing it here. But if you are doing organic chemistry, you have to show the catalyst. We move on. Now let's look at the reactions of chromium. Here we can as well say the chemical properties of chromium. Chemical properties of chromium. So we say that, we start from here, we say that chromium is a bluish white metal. So here we are trying to show the color of chromium. Chromium is a bluish white metal with a melting point of 2163 kelvins. So this is supposed maybe to come under physical property, but we needed to know what are we dealing with, so that when you're writing, let's say, the observation, you can return the original color. Reaction number 1, reaction with air. Chromium is not affected by air at ordinary temperature, but if we are to do it in our ordinary lab, we might maybe come to conclusion that it does not react, but it does so. That is after applying enough heat. Some books say when it is red hot, that is when it is very hot, then it is going to be oxidized to a green chromium 3 oxide. So we shall form a green solid of chromium 3 oxide. So we are having chromium here, we say that it is a bluish white metal and is reacting with oxygen from air. Then we form a green solid of chromium 3 oxide. Then with water, reaction of chromium with water. Chromium does not react with cold water. This is a condition that we need to take note of. Chromium does not react with water, but at red hot. When we say red hot, that is when chromium is heated. That is another condition. It is going to react with steam. When we talk of steam, that is water in a gaseous form, or when you heat water and that vapor starts coming out to form chromium 3 oxide. So what is important here is that to know that chromium does not react with cold water, but once the water is heated into steam, then there would be a reaction. And we also make sure that the chromium metal is also heated. So there is the equation. So we are having chromium and it is reacting with steam. Steam, to show that the water in the steam form, you make sure that you give it a gaseous state. You have to give it a gaseous state, so that is steam. Then we are forming, this is a green solid, chromium 3 oxide, and a colorless gas, that is hydrogen. So if they ask you the reaction of chromium with water, you have to state that it doesn't react with cold water, but when it is heated, it can react with steam to form a green solid. That would be part of your observation. Then with halogens, we can say that chlorine and fluorine combines with hot metal. So still we have a condition of heat. To have it hot, or to have them hot, it means that you must apply heat. So one of the conditions is that there must be heat to form chromium 3 halides. In other words, if you had used chlorine, it would be chromium 3 chloride. If you had used fluorine, it would be chromium 3 fluoride. So those are this is the general equation. This is the general equation whereby X stands for the halogens. In this case, we are dealing with chlorine and fluorine. So we are saying that X is either chlorine or fluorine. But make sure if you are to use the general equation, you have to put a key, like you have to describe if it is x, what is x, other than leaving it like that. If you don't do that, it means that we shall need to look for an element called x, or an element which has got the symbol as x. For example, if we choose maybe one of the two elements, we can say chromium reacting with chlorine, and we are forming chromium 3 chloride. Then also fluorine reacts with chromium at this temperature. So here we are being specific. There is heating, but this is the particular temperature and also pressure of 200 atmospheres to form a yellow solid. Of chromium 6 fluoride. So that is with fluorine. So once again, what you need to know is that about this reaction, the gases, this chlorine and fluorine must be dry, and also heat must be applied. And in case you have to answer this and you're not sure of the temperature, please, you can leave it out so that you don't make a mistake. Maybe you put a wrong temperature, you put wrong conditions. Normally this question comes in paper 1 where they're asking the conditions for a particular reaction. But the most important conditions are that chlorine must be dry and heat must be applied. Then we look at reaction with nitrogen or ammonia. Reaction with nitrogen or ammonia. It reacts with ammonia or nitrogen to form nitrides. In other words, it is capable of reacting with the inactive or the inert nitrogen, just like what magnesium does, or aluminium. So we have that equation. We are having chromium reacting with ammonia gas. Then we are forming chromium nitrides and also hydrogen gas. It also reacts with nitrogen in the following equation below. So we are also forming chromium nitride. Then again, chromium does not react with alkalis at ordinary temperature. Chromium does not react with alkalis at ordinary temperature. We shall have more details about this kind of reaction later. Then we look at the reaction of chromium with acids. So we say that in absence of air, dilute hydrochloric acid and dilute sulfuric acid react to form corresponding chromium 2 salts. This happens if the two acids are dilute. But if they are concentrated, maybe we are likely to get a different observation or different reaction. So here we have a general equation where we have chromium reacting with dilute acid. That is where we are having the hydrogen ions from the acid. Then we form chromium 2 salt and also hydrogen gas. So you can substitute these hydrogen ions with one of the acids. If it is, for example, dilute hydrochloric acid, then you form chromium 2 chloride and hydrogen gas. But remember, we said these are blue. This is a blue solution. In other words, chromium 2 ions in solution, they are blue. They are blue in color. Those are chromium 2 ions. But remember, we said that when the compounds which are formed in positive 2 oxidation states, they are unstable. In other words, once you form a compound in positive 2 oxidation state, it means that there are chances of it getting oxidized to a stable oxidation state, and that happens in the presence of air. And that is why here we are having our reaction in absence of air, to make sure that the chromium 2 formed does not get oxidized to chromium, chromium 3. So we are saying that chromium 2 is unstable, therefore it is readily oxidized to a green chromium 3 salts. So positive 3 is the stable oxidation state, whereby the chromium 2 gets oxidized to in the presence of air. So the air contributes much to the oxidation of chromium 2 ions. So there we have the equation. So we are having chromium 2 ions being oxidized to chromium 3 ions. And remember, oxidation, we can define it as the loss of electrons. So in chromium 2 we had lost only 2, but in chromium 3 we lost 3. In other words, we lost 1 more electron. And then again, chromium does not react with nitric acid due to the formation of a protective layer. Some books will say nitric acid renders passive. In other words, does not react with the chromium. At times we say it does not react with chromium at all conditions. We move on. Now, having looked at those few examples, those few reactions, here we have our exercise that we need to try out. So what we shall do, these notes will be downloaded to our Google Classroom, and this is the class code, and this is the class code to our Google Classroom. In case you don't know how to use the class code, down below in the description there is a link that will take you to the Google Classroom of Senior 5. So what you need to do is to check in the description, then you click on the link, then straight away it will take you to the Google Classroom. And make sure that you first download the Google Classroom app, and if you don't have, then there is also a link provided for you to be able to download the Google Classroom. So don't forget to share the video and subscribe for more videos, and also to be able to watch the previous lessons that you might have. So thank you and God bless you once again. Don't forget to subscribe.